Hi guys, in this video I'm going to discuss an interesting question from Annular wheel. Also it has been related to instantaneous center. I have already done many questions regarding instantaneous center velocities. If you haven't watched them yet, just I have given the link in the description so you can always watch that. After that, please continue this because it would be a little bit difficult than other questions. If you are new to this channel, don't forget to subscribe it. Let's read the question. As you can see over here, there are two wheels, and the main thing is this A is known as annular wheel. So it's a kind of a setup normally used in mechanics. So as you can always see here, we are going to call this circle as annular wheel. Also, we are going to call this gear or the circle part as planet wheel. The thing is here, the thing going to happen over here is we have connected this planet wheel using a rod to a fixed point called O. So we are going to give a velocity of omega L, angular velocity of omega L for that rod. Also, we are not giving a separate velocity for this planet wheel. As it's connected to this rod, it's going to have that part of this omega L. So here we haven't connected this planet wheel to a fixed point, but we have connected through a connecting rod, and the connected rod is having a angular velocity of omega L with respect to this fixed point O. So the next part is the annular wheel. The annular wheel is also centered, fixed in that center point called O, and it's going to rotate on that axis with an angular velocity of omega A. So this is a simple part. You have different equations to solve this, so I'm going to explain that. It's easy to memorize those. Also, the main thing is that I'm going to read these four questions. As you can always see here, the first part they have asked to prove that omega P is equal to 4 omega A minus 3 omega L. What's meant by omega P is, as I have already mentioned, we are not going to give an angular velocity directly for this planet wheel. So what's going to happen is, by the rotation of this annular wheel as well as this omega L, the connecting rod's angular velocity, it's going to have an angular velocity in its own, which simply means if I'm going to rotate this on this path, this planet wheel is going to rotate in this annular wheel part as well as using this omega L2. So for that you need to know the equation, otherwise it would be a little bit difficult to find this omega P in respect of omega A as well as omega L. The second part is we need to find what's the instantaneous center of P's rotation along Q. So here, as you can always see here, in this planet wheel, I have already mentioned, it's going to have an angular velocity, but we need to find, because we are not giving that angular velocity directly, it's going to have that angular velocity because of this omega L as well as omega A. So the first of all, we need to find this omega P, as well as using that we need to find what's the velocity on it. After that we can find what's the instantaneous center of this rotation, P's rotation, from the PQ axis. So they are mentioned from this OQ axis, we need to find where is that instantaneous center from this Q. What's the distance between the instantaneous center from this Q? So we need to find that also. The third part is they are asking locus of instantaneous center of P, which simply means it's going to rotate. As I already mentioned, it's going to rotate. So if we find any instantaneous center over here, what's going to be its path? So that's the thing they are asking. So we need to find that also. After that, they are asking a simple question to deduce what happens when omega A is equals to 0.75 omega L. So after finding all this, we can easily figure it out. So first of all, we need to find what's this 4 omega A and 3 omega L. For that, I have already mentioned we have a simple equation, so we need to memorize, otherwise it would be a little bit difficult for you guys. So the equation is, first of all, I'm going to tell when can we use this equation. if this connecting rod is moving, it's rotating, and the annular wheels also, we are giving an angular velocity for annular wheel also. So if these both rotation are in the same direction, we can use this equation. That's a simple thing. So you need to memorize this equation. After that, you can use it when you have seen these both rotation are in the same side. If any of these are in the opposite direction, you need to use minus sign instead of using the plus sign. If the omega L is in the anti-clockwise direction, you need to use minus omega L value for that equation. So the equation is derived for the annular wheel and the connecting rod's velocity, angular velocity in the same direction. So I'm going to write the equation. Omega P would be equals to 1, it should be minus. So 1 minus the radius of annular wheel, or a radius of annular wheel, over radius of planet wheel into omega L. So this is the equation. After that, you need to add the velocity, the angular velocity, which is going to get using this omega A. This omega L, we have written this part, it's going to be the component because of this omega L. As we are rotating this omega L, the planet wheel is going to have this omega P component. This is a component. After that, we are also rotating the annular wheel. It's also going to give some part of this that's angular velocity to him. What would be that is RA over RP into omega A. So this is the equation. So please remember that you need to remember this equation, and you need to use this when both these are in the same direction, either in clockwise or anti-clockwise. If there is one is rotating in the opposite side, you need to use minus sign over here. For let's say if the omega L is in the left hand side, anti-clockwise side, you need to use minus sign over here. So here we are going to directly substitute, but the answer is given in the omega N and omega L. So we can directly tell we need to find this RA and RP. So we have given that this is the radius of planet wheel. So we have already found that the RP is going to be this R, as this is the circle from the center is Q. The next part is we need to find this RA. This RA would be, we can also find it over here, as it's the center of O is the center of this annular wheel. We can find this radius, which would be equals to 4R, as it's 3R, as well as there's the R over here, so it's going to be 4R. So I'm going to directly substitute over here. If I substitute, so 4R over R omega L plus 4R over R omega A, I'm going to get the answer. So what would be the answer is minus 3 omega L plus 4 omega A. So I have finished this. So the next part is they have asked what would be the instantaneous center of P. So for that, I have in my previous videos, I have already directed that when you are going to find the instantaneous center, you need to know at least 2 directions of the velocity of that rotation in the 2 points, as well as you need to know 1 magnitude point to find the instantaneous center. So that's the basic requirement you need to have over here. So here I'm going to find that using that method. So let's say if I draw that planet wheel, I need to find that planet wheel, so I'm not going to draw only that part. So here we can mark it as Q. I'm not good at drawing, so let's okay. Here I have got a circle. So we can tell that the thing is what's going to happen over here. If I consider this part, as I have already found, the omega P is going to have in this direction, as it's, let's say it's going to be positive. Surely we don't know, but we can assume because we don't know what's the values for those things. So let's say it's in this direction, omega p. So the next thing is we need to have what's the velocity over here, or in these points, or in this point, what's the velocity over that. So here the thing is we can use this part too. As you can see over here, the center part's velocity would be omega L into 3r, because the center part is fixed from this O axis, as it's having a connected rod. So we can directly tell the center part's velocity would be omega L into 3r. That's the secret hidden information inside this. So we can directly tell it's going to be omega L 3r, but remember this is the velocity of that center point. But the thing is, this we are also having this omega p. What's going to happen by that? For that, as you can always remember in your previous questions, it's going to be v plus r into omega p. V plus r into omega p. If you need, you can find this value also. It's going to be v minus r omega p, but we actually don't want to mark that, because we can found the instantaneous center using these 2 points. So I have already mentioned the basic requirement is only 2 points. So the thing over here is, some might have a doubt, why are we using this v plus this r omega p? Can't we use that 3r into omega p? So in a circle you will always know, let's say it's going to rotate over here. We can directly tell this is going to be r omega, then this is minus r omega. So this is plus r omega in this opposite direction. Let's say it's in the fixed point and it's going to rotate over here. Likewise, when you are seeing this omega p, which simply means this planet wheel is going to rotate in its axis, own axis. So we can directly tell, if you don't consider anything over that v also, it's going to rotate over this point. So if it's going to rotate over this point, we can tell the velocity given or get by this omega p is going to be r into omega p. Radius into angular velocity would be the real velocity. So from that, we already knew that it's also going to have this velocity part because of this movement of this connecting rod. So we can directly tell it's going to be v plus r omega p, but be careful, we need to put this r. We can't use this 3r over here. The reason is, it's the omega p is the angular velocity, because the planet is having the rotation of its own axis. So we can directly tell from this own axis is going to be r, so we can directly use this r omega p. So the thing is, we need to find the instantaneous center. So I'm going to draw a triangle like over here. So let's say here is the instantaneous center. So from Q we need to find that. They have asked from the Q point, so I'm going to mark it as x, and we also knew the value of this r. So from that we need to find over here the value of that. So we can directly use the equations for this triangle. Let's say it's going to be, as it's a triangle, you can see they are in the same angle. These two sides both are in the same angles. We can directly use x over x plus r. Let's say I'm going to consider this triangle versus this triangle. So in this triangle it's going to be x, and this triangle in the side, the left side would be x plus r. The next part is, I'm going to substitute this part. It's going to be, for this triangle it's going to be v, which is omega L over 3r. The next part over here it's going to be b plus r omega p. I'm going to put omega L 3r plus r omega p. So if I simplify this, I'm going to simplify because I need to find the value of x. So if I simplify this, x into omega L 3r plus r omega p is equals to x omega L 3r plus r omega L 3r. By simplifying this, you can get an equation. After that, you need to substitute this value 4 omega a minus 3 omega l, and you can get this answer. So this is a simple thing. The basic thing is, you need to know what's happening over here, and you need to memorize this equation. The next part is they are asking about the locus of instantaneous center of P. So here we have found that if the instantaneous center of this P is going to be from this Q point to this here, over here, let's say it's in this point. So what's going to happen over here? Let's say when it's rotating, we already knew the R is not going to change, as the radius of the R not going to change, and the omega is not going to change, and the omega L also we are not changing, as we can assume as they are constant velocity, angular velocities. So we can directly tell it's not going to change, which simply means if this planet wheel is rotating over this side, this instantaneous center is also having a circular path, and the center of that circular path would be this O. So it's also having a rotational, so circular motion with the axis would be this O. So the locus of the instantaneous center of P would be a circle. The center of that circle would be O. So the next question they are asking about what happens when omega A is equal to 0.75 omega L. So when I did this question in the first time, I have just directly substitute this omega 75 L, sorry, 0.75 omega L in this. If I substitute over here, I will be getting 3R over 0. So it means the instantaneous center of this P would be in this infinity. So can I write it as that in the exam? So it's not good, it's not fair. So what we can do is we can directly substitute over here this equation. If I substitute over here, I'll be getting omega A is equals to 0. In the D part, I'm going to get omega P is equals to 0, which simply means it's not going to rotate. If it's not going to rotate, which means it's going to rotate over here because of this omega, the connecting rod velocity, it's going to move like this way, but the thing is it's not going to rotate in its own axis. So omega P is equals to 0, which simply means it's going to be stiff and it's going to move like this. So from that we can directly tell, as it's not going to rotate on its own axis, it's not going to have its instantaneous center, as they are all are in the same velocity. If I consider a circle like this, as it's not going to rotate over here, the value of the all points, the velocity of the all points is going to be the same in this axis. So we can directly tell, as if the omega P is equals to 0, it's not going to rotate in its own axis, but it will rotate from this O axis. So as a circle, it's going to move like this. So this is a question I have found when I'm doing. So I hope this question would be interesting for you. If you have any doubts, please let me know. Thank you.